Factoring using the greatest common factor. That means we're going to look at all of the components of the equation or expression, and we're going to pull out the largest thing that is in common between each term. For example, if we have 5p plus 25. 5p is comprised of 5 times p. 25 is comprised of 5 times 5. So if we look at these two terms, the thing that is in common is a 5. That's all that's in common, so that is our greatest common factor. If we pull out a 5, here we're left with just a p. We have plus before, so it stays plus. Here we're left with a 5. What we have done by factoring is undone the distribution property. This is factored form. This is finished right here, it's factored. If you were to distribute your 5, you'll get right back to where you started with our 5p plus 25. That's how you can check to make sure you have it right. Let's try again. So this one's a little bit more complicated. We don't want to have to always write out every single piece like we did in the last one for the 5 times p and the 5 times 5. So this one we need to think. We need to think of the factors of 45, and we need to think of the factors of 60. And let's think about the highest number that's in common to both. Hopefully you recognize that 45 is 15 times 3, and 60 is 15 times 4. Then we can see we have a common factor of 15, but there's more than that in common. Here we have y to the 12th, here we have y to the 10th. So this means y times itself 12 times, and this means y times itself 10 times. So we also have a lot of y's in common. Here there would be 12, here there would be 10, so that means there are 10 in common to both. So what that looks like, if we pull out a 15, and we pull out y to the 10th. Well here, 15 times 3 is 45, so I'm left with a 3. Y to the 10th, well I had 12, I took 10 of them away, so that means y to the 2nd is left over. I had a positive, I did not pull out any negatives, so plus from right here. I had 60, I pulled out, so I divided out a 15, so that leaves with 4. I also divided out 10y, so there's no y's left over. So that would be factored form. If you distribute back, you'll get back to your original expression. Let's try again. Negative 15, y to the 3rd, z to the 5th, minus 28, y to the 3rd, z to the 6th, plus 9x y to the 2nd, z to the 2nd. So now we need to look through all of these different pieces and see what we can find that's in common. Well, let's start looking. 15, well, that's 5 and 3. 28, that's 7 and 4, or 2 and 14. 9, that's 3 and 3. So it doesn't sound like there's any numbers that are in common. That's okay, let's move on. Here I have y to the 3rd, here I have y to the 3rd, here I have y to the 2nd. So I can take out y to the 2nd from each piece. Let's see what else we can do. Z to the 5th, z to the 6th, z to the 2nd. So each one also has z to the 2nd. So if we pull out y to the 2nd, z to the 2nd, we need to figure out what's left over. Well, if I had z to the 3rd, and I took out z to the 2nd, I have if I have y to the 3rd, and I take out y to the 2nd, I have y to the 1st left. If I had z to the 5th, and I took out z to the 2nd, I have z to the 3rd left. So that means from our first term, we have negative 15 y z to the 3rd. Let's try the next one. I had 28. I didn't take anything out. That stays the same. I had z to the third. I said it again. I had y to the third. I took out y to the second. So that means we have y to the first left over. I had z to the sixth. I took out z to the second. So that means we have z to the fourth left over. We did not change anything with the 9. I did not have any x's to pull out. I pulled out y to the second, so I had y to the second, so that's gone. I pulled out z to the second. I had z to the second, so that's gone. So this would be the factored form. Let's try again. -5 p to the sixth, q to the third, minus 10 p to the fourth, q to the fourth, plus 25 p q to the seventh. So let's look through. 5, 10, 25. So I can take a 5 out of all of those. And then let's look at the p's and the q's. Well, this one only has one p. So these have more, but that means I can only take 1 from each one. Here I have q to the 7, q to the 4, q to the third, so that looks like I can only take 3 from each. So let's see what's left over. If I take out a 5 from a -5, that leaves me with -1. If I take out 1p, I had 6, I take 1 out, so I'm left with p to the 5th. I had 3 q's, I take them all out, so no more q's. Minus, I had 10, I took out 5, so 10 divided by 5 leaves us with 2. I had p to the 4th, I took out p, so that leaves us with p to the 3rd. I had q to the 4th, I took out q to the 3rd, so that leaves just q. I had 25, I divided by 5, so that leaves us with 5. I had p, I took 1 out, so none are left. I had q to the 7th, I took q to the 3rd out, so that leaves us with q to the 4th. You can always check by distributing back. When you distribute back, you'll multiply the numbers and you'll add your exponents, and you'll get right back to what we had here. Let's try again. Let's say you have y times b minus 2 plus 5 times b minus 2. So when you look at this one, what is in common? It's a little bit more tricky, but if you notice that b minus 2 is what's in common between our two parts. B minus 2 right here, b minus 2 right here. So if I pull out what's in common, b minus 2, then I write down what's left over. Well, I'm pulling out what's in common, so pretend I just erased it. That would have a y left over. Just erase what's in common. That has a 5 left over. There we go.